This is my flashing LED project for www.stakey.co.uk. My brief was to have a low power flashing LED with a period of around 4 seconds. The battery should last unchanged for 2 years, or at least 2 years. The rest was up to me. If you'd read my blog posts, then you can just watch the LED flash, otherwise let's get started. The first thing when people say flashing LED is use a 555 timer. Now the lowest power 555 I could find still had a current draw of 60 microamps, even without flashing LED. 60 microamps on a 1 amp hour battery wouldn't even last 2 years. So that timer is useless for this application really. The next thing would be using a low power microcontroller. I think the PIC 18LF 14K22 has a low power sleep mode that takes, I think it's 460 nanoamps sleeping, which is what, 5.5 years. Well, I think it's something stupid. It's like 200 years if you just left it sleeping. As soon as you want to wake up and flash a light, then I think you're looking at 5.5 years. Now the great thing about using a microcontroller is you can do extra fun stuff like double flashing the LED. For a start is easy. You can reverse bias your LED and use it to have ambient light detection. So you can change your behaviour of the LED during the night time or at night, daytime or at night. I didn't go for the microcontroller route, and the reason for that is I felt like it was a bit of a waste of technology. I don't think it's cheating, but I think the technology could be used for something so much better than a flashing light. So that's why I went with my final choice, which was it's based around a square wave generator using an op amp. My circuit was designed and simulated in LT Spice. I'm just going to flip up to that now. There we go, so that's my circuit. I just briefly described the operation. This capacitor is uncharged at the moment, so this point here would be effectively 0. This switches this point on, which switches the LED on, but also charges that capacitor through this diode and this resistor here. So this charges up until this point is higher than this point. Then that'll switch off, the light will go off, and this capacitor would discharge only through this path here. Now I simulated this, and here we go. This is the voltage, this is the current. My voltage, it's running off 2 AA batteries, so I've got around 3 volts, and it's giving me a period of around 4 seconds, and its on time is about 100 milliseconds. The current draw, I've got a peak current of just about 5 milliamps, but my average current consumption is 26 microamps, which for the 1 milliamp hour battery gives 5 years, which is well in excess of the 2 years that I've been aiming for. Just a note about the PCB design. I'm using 4 PCBs here. The top one is just a backing plate for my mounting. It's completely blank. There's just copper on the other side, no track routing or anything. I've got 2 PCBs in the middle that are similar to this, but they've got a square cutout in the middle to act as a recess from my electronics. And then the 4th PCB is a single side surface mount design, with the exception of the battery and the LED. There's nothing else I can really say. I've got it's 5mm holes drilled there and there, so mounting options are either screw it wherever it's supposed to go, or glue it. The idea is it sits inside a dummy security camera to give that extra sense of realism. That's it really. Thanks for watching.